Okay, welcome to the third segment of Living Wisely in Wales Spring Series.
Thank you.
Judy Preston will be speaking tonight about gardening practices that promote a healthy environment. She is the Long Island Sound Outreach Coordinator for Connecticut Sea Grant and has been doing community-based conservation in Connecticut for over 25 years. Judy will explain what native is, why it matters, and how to attract and sustain wildlife while reducing water, fertilizer, and chemicals. As a consultant, she advises how to create ecological gardens and provides education on environmental issues being faced by the Long Island Sound. Judy describes herself as passionate about the natural world, gardening, and gunk holing in the Connecticut River estuary. So welcome, Judy. We want to hear about it all, especially the gunk holing.
Well, thank you. I put that word in there because I love that word, but it also, it means basically messing around in small boats in inlets and tidal areas. So just kind of gunk holing, going around in shallow gunk areas. And it's a great word.
Yes, it really is. It's the first time I've heard it.
So can I go ahead and share a screen, and then I'll get started with the talk unless anyone has an advanced question. No advanced questions. So let me share my screen and we can get started.
And I would ask, if you are not the presenter, would you please mute yourself?
Okay. All right, everybody should be seeing my screen, yes? Can everybody see? Can everybody hear me?
Yes. Yep, we've got it.
Okay, so are you seeing the picture?
Yes.
Okay. Okay. So, I think as Michaela said, and I want to thank everybody for inviting me actually this evening, because I love speaking about Long Island Sound and about gardening. And in fact, in my time with the Long Island Sound Study and Connecticut Sea Grant, I really focused on making the link between the two, which is not always an obvious link, but that's, I'm hoping in part to help explain this evening. I am a passionate gardener, I must say, among all things, and now more than ever before, after really feeling cooped up for the past year. So I'm in the process of tearing apart my backyard in an effort to really commit myself to gardening in the coming year. So let's get started. I'm guessing that probably many, if not most of you, if not all of you, have heard of Doug Ptolemy, who is the entomologist at the University of Delaware, who has launched himself forever into the hearts of gardeners and conservationists by making the very essential link between, in his case, insects, but he doesn't really stop at insects. He really talks about biological diversity and how important, having a healthy environment is for so many things. He obviously is a bug person, so he can speak pretty passionately about bugs, but he goes on to, explain the connections between bugs and birds and, healthy plants. And ultimately, it's an ecological way to assess how we're doing. And I love this quote. He's got several books out now. This was from his first, Bringing Nature Home, where he said, for the first time in history, gardens have taken on a role that transcends the gardener. And I love that because I feel like gardens for so long have been really, for curb appeal. They have been for supposedly for weekend, relaxation, although I have to say that, as we evolved into a lawn culture, I don't see that the relationship between relaxing and having lawns, but we'll get into lawns because that will be part of the story. So Doug Ptolemy makes the connection between, again, having a healthy environment can start with small steps and can graduate into much larger impacts having to do with a healthy environment. And that is in part what everybody's interested in. So I am going to connect us to Long Island Sound since we are all neighbors to this incredible estuary that's right along our entire shoreline. And really the story of having healthy gardens is part of looking at the much larger picture of the entire watershed. And the watershed for Long Island Sound is huge. The Connecticut River, which is the largest river system of Connecticut's big three rivers, contributes 70% of the fresh water to help make the estuary of Long Island Sound. Goes all the way up to, in fact, into Canada, into Quebec. So 410 miles to the north. And if you live in Connecticut, the chances are very good that you live within the watershed for Long Island Sound, which means anything that you do in your backyard has the potential to have an impact. And even though people can argue, if you're in Quebec, it's hardly likely that the impact that you're going to have is going to impact, is going to make a difference in Long Island Sound. But the more people that we have occupying this watershed, and particularly New England, the more potential there is and the more probability there is that the impacts that we have collectively make a difference. So as we add excess fertilizers, excess nutrients, excess toxins and chemicals to even the Connecticut River, but all of our even smaller river systems that ultimately make it into Long Island Sound, that collectively makes a difference. So I like to look at the estuary of Long Island Sound as being, the ultimate disposition of a lot of people doing things in their yards. And that can have an impact, right down to ground nesting bees. The bee in this picture is one of our native bees, a Calides bee that I found in my backyard. I was so excited. And not only Doug Ptolemy, but there are a bunch of other people who are now really bringing to the fore the idea of pollinations, pollinators, and looking at bees and insects, not just honeybees and pretty butterflies, but there are so many organisms, small organisms that are essential to healthy ecosystems. And of course, if you think of insects as fuel for birds, for chickadees, for example, in this picture, but also the relationship then between healthy input of what an estuary is known for. An estuary by definition is the meeting of land waters and ocean waters. And they are extremely rich because of the nutrients that are coming from both of those big ecosystems. The ocean brings in certain elements, and what's coming in off of the land in the continental or the land body is different and equally important. All this organic material that's coming in. So that fuels fish. And of course, migratory fish are such a great way to describe this relationship between ocean and land, and ultimately where the two meet in an estuary such as Long Island Sound, because ocean anadromous fish spend their adult years out in the ocean waters, but come to our freshwater water bodies to spawn. And of course, that becomes food for some of our migratory and non-migratory predatory birds, such as the osprey and the eagles. So rather appropriately, I think I like to think of estuaries as being the gardens of the sea, because they are. Of all the ocean environments, you have deep ocean, you have off the continental shelf, but it's the areas that are close to our land bodies that are reasonably shallow. The average depth of Long Island Sound is about 65 feet, which is pretty shallow. And there's a good area when you look at the North Shore of Long Island and the coast of Connecticut of reasonably shallow areas, and of course it's tidal, that provide areas Is it great to do a global mute?
Somebody named Christine needs,
Let's see if I can I mute everybody or can only the, I think maybe on your end, it can be muted.
Yeah, I'm working on it. I have to keep going through the list of participants to see who's not muted.
Not muted, yeah, okay. At any rate, so estuaries are incredibly important, and that also makes them very vulnerable because they are coastal. And we think of all the big cities that are located along coastal areas, and that puts pressure on estuaries. And estuaries are phenomenally productive systems because they are shallow, because the sun penetrates, there's high primary productivity. It's also the place where many fish and other wildlife species come to reproduce. I mean, you think of all the nursery fish that are using the waters and the shallow areas along our coastal rivers to protect their young, to raise their young, protect their young, keep them away from predators, and then send them off into their adult lives, either in the estuary or in the ocean beyond. But you also think of, you know, the good fish food that you love to eat, the fish and invertebrates, you know, the crabs and what used to be our lobster fisheries here. But globally, these are all important, you know, high energy, high primary productivity, producing lots of food, you know, our recreational fish as well as our commercial fisheries. But also think of the coastal marshes that rim all of these areas. In Long Island Sound, it's our coastal marshes that are so important for, particularly right now, because we have a lot of birds coming in, a lot of migrating birds that are coming into our marshes right now. Some of them are going to stick around for the summer. Some of them are going to land in our marshes and hope to refuel in order to get further either north or you know, go up the Hudson River or continue on east and up to the Cape, and some of them will continue on up from there. All of them looking for the resources from these really high productivity ecosystems. And these marshes are also critical as they filter pollutants, very convenient because they're rimming the area of our uplands that are producing a lot of issues having to do with pollutants and, you know, excess nutrients. Storm buffers, we've seen this with our increasing frequency and intensity of storms, that those communities that have left large areas of wetlands, particularly with marshes, fare better during these wind and storm events, because these marshes can absorb tremendous amounts of abuse, water and wind, and that can protect the land use behind those. And now that we're really concentrating on carbon sequestration, having to do with the total amount of carbon dioxide in our atmosphere, these ecosystems are taking on even greater significance. So Long Island Sound is an estuary of national significance. It was designated by our Congress in the late 80s because it is such a concentration of life, both in and on the surface of this water. And that's not unique necessarily to Long Island Sound. All estuaries, in fact, if you go online, you can look at estuaries globally and you can see that, you know, there are tremendous estuaries. But what is unique about this particular estuary, a couple of things. One is it's often called the urban sea, in part because our land use history, certainly in terms of European settlement, goes back a long enough time so that we have a pretty significant input of human development and longevity in this landscape. And that is both what makes our human populations interesting and our landscape interesting, but it's also part of what pressures our estuary in terms of excess nutrients in particular, but also in a lot of emerging contaminants that we're starting to become aware of and also starting to track. So if you look at the concentration of species, 1,200 species of invertebrates, that includes the good things that we like to eat, like crabs, but it also, there's a huge amount of small organisms that you and I probably have not ever seen or may not ever see, but are still extremely important part of the productivity of Long Island Sound. And the migratory birds that are going to be coming in. I love that the osprey are already here, already setting up housekeeping. Lots of the birds have come in and many more are on the way. I put this picture together because these are some of the images of organisms that we can find in Long Island Sound, but the fact that they are in Long Island Sound, many of them so small, they're in the water column of Long Island Sound, and we will probably not see them. We can see seagrass, the seagrass that you can see in the lower right-hand corner, and those are incredibly important habitats. Shallow, they are submerged. They're called submerged aquatic vegetation, and it's similar to kelp and similar to some other seaweeds, but these photosynthesize water because they're in the shallow areas. And so they're also sensitive to water quality. They cannot live in an area where that's clouded because of too many particulates in the water. They're also sensitive to chemicals in the water, to turbidity, to boat traffic, and to pollution. So what historically was a rim of green seagrass that went all the way down to Greenwich along our coast is now pretty much isolated to the southeast shore of Connecticut. And the Long Island Sound Study, which is a part of the National Estuary Program and is operated by the Environmental Protection Agency, is looking at seagrass as a metric that we're going to continue to track the success of seagrass, because it's going to tell us how we're doing with cleaning the water in Long Island Sound. If we continue to lose our seagrass beds, which is also an important nursery area for fish and for invertebrates, then that's telling us we need to work harder at that particular issue. But a lot of these other things, you can see down on the bottom, the northern anemone. Now that's, I'll be referring back to that in just a minute, but those are, to me, that looks like something tropical, like it must live somewhere other than in Long Island Sound. But if you look at some of the rare photographs that we have of the life that's in Long Island Sound, this anemone it's a bright orange, and they live on the bottom of Long Island Sound. And similarly, you know, these other species, the northern cup coral, for example, the nudibranch, the sea nettles, all of these extraordinary forms of life. So when we're talking about Long Island Sound, and I in particular as someone who's trying to engage people in protecting Long Island Sound, it's not always easy for people, to gain access to Long Island Sound, but also even to see just the myriad life forms that we're talking about when we try to help people understand why, you know, putting a lot of fertilizer on your lawn is actually having an impact to organisms that you may never see, but they're important. So did I mention the quiz? I'm kidding.
It's okay.
So I'm going to talk just a moment about hypoxia, because hypoxia has, for the over 25 years that the Long Island Sound Study has been working on Long Island Sound with many partners from both states of New York and Connecticut, excess nitrogen in Long Island Sound has been the top priority. It still continues to be a top priority, although we are happy to say that the extent of the hypoxia, which is low oxygen levels, and I'll explain that in just a moment, has actually been reduced over the last 10, 15 years in particular. And we're very excited about that. The downside of that is that more research that's been done by Dr. Jamie Baudry at the Marine Sciences Program at the University of Connecticut, along with her cohorts, have done a study that looked at 110 coves and embayments along the Connecticut and Long Island coast to see how are we doing with low oxygen levels in our coves and embayments, the mouths of the many rivers. Connecticut has over 50 small rivers, as well as the 3 big rivers. So how are they doing? How are some of the coves? I live on South Cove in Old Saybrook. How is South Cove doing when it comes to the ability to support life And what she discovered is, ooh, yeah, we've got some problems there. Not every cove and embayment has a problem, but there are some real hot spots. And the bad news is, of course, that that's directly related to land use and probably pretty significantly to local land use. The good news is it gets us thinking about what we can see from our backyards or from our communities or from our favorite beach or from our favorite place that we go to either smell the salt air and see Long Island Sound. It gets to be much more of a, I can see that in my backyard. And that's helpful for me and for other people who want everyone to know that you really can make a difference if you want to protect what you love about Long Island Sound. So here's the anemone again, and I'm putting that picture down there because anemone are fixed organisms. They live on the bottom of Long Island Sound. They don't have the ability to move around. So let's look at what hypoxia is. You get a storm event, think a hot summer day. Let's think of July, maybe mid-July. We haven't had rain for a couple of weeks. Think of the parking lot of your local big grocery store. In my case, Big Y or Stop and Shop. Think of all of the cars that have parked in that parking lot. Then think of, after 3 weeks of hot, dry weather, we get a gullywomper. We get a really big storm. And actually, these storms are increasing in frequency and duration and just the damage that they can do. So you get this huge influx of water. What happens to that water on that big black tar? Which, if I'm sure that you've all seen this, when you walk from your car into the store, sometimes you walk across areas where cars have leaked, where you can see the hydrocarbons, you can see oil, you can see gas, you can see a variety of things. Cars are absolutely necessary, and they're one of them. In fact, the Connecticut's the organization that tracks what you can and cannot do in Connecticut says that the one most important thing that you can do to help the environment is to stop driving your car. It's not possible, but our cars really, even, every time you put your brakes on, you peel a little thin layer of some of the zinc and cadmium and nickel, some of these really toxic ingredients that come off. So these parking lots are concentrated with a lot of stuff. You get that big pulse of storm water and it goes away. And where it's going, of course, is to the local storm drain. And the problem with storm drains, the good news is storm drains take care of that water. That's what they're designed to do. And the parking lots have been designed to make sure that the water goes as quickly and as efficiently to those storm drains as possible. The problem is that storm drains have very little ability to remediate whatever is going in that water, particularly if there's a lot of energy behind it. So we have that gullywomper and the water just charges and it goes into those storm drains. And very often those storm drains, other than taking out large particle like garbage, will just go directly into the receiving waters. And if we live on the coast, that's exactly where that water is going. So now you've got a lot of things. You also think of how many people are fertilizing their lawns this time of year, early in the spring, with the idea that with rain, it will soak into the lawn. And that's a common practice. My dad used to do that all the time. Oh, it's gonna rain, I'm gonna go out and put fertilizer down. And the problem with that scenario, of course, is if there's too much rain or if there's more nutrients in that fertilizer than your lawn actually needs, it either washes off as storm water and again makes it into the lowest area, which would be Long Island Sound, or it goes into the ground and ends up polluting groundwater. So all of that's a bad scenario because there's nitrogen, there's a lot of things, but nitrogen in particular is a problem for Long Island Sound because as a coastal system, it's nitrogen limited, which means it's not used to having a lot of, in a natural environment, it would not have a lot of nitrogen. But because of a land use, because of the sources of nitrogen that come off of our landscape, in addition to water that comes from sewage treatment you know, we've reduced a lot and we've done a lot. We collectively, the states of Connecticut and New York, to reduce the amount of nitrogen that's coming from those sources. But we still have a lot of people that we're trying to accommodate in these coasts. So the nitrogen enters Long Island Sound, and that is a food source for algae. And we're noticing that as time goes on, we're starting to see more algal blooms. Some of these are more dangerous than others. Some of these are associated with cyanobacteria. Some of these are associated with paralytic shellfish poisoning. So we're starting to have a problem with that in its own right. But eventually, because these systems pulse, because the rain comes and then it goes, the pulse of nitrogen that's available to algae uses it all up. It reproduces dramatically until there's no more nitrogen to feed it. And then they can't support themselves and they die. That's when the system starts going for hypoxia, because the algae will die. They will sift down through the water column, where as they get lower in the water column, the bacteria will start to eat the dead algae. And in so doing, they take oxygen out of the water. And that's where we start with a problem of low oxygen. If there's a lot of nitrogen, if there's a huge bloom of algae and that all dies, we get more of the bacteria and we get more of the oxygen being sucked up. So now you know what hypoxia is and why it's such a problem, because you can imagine if you are a fish, you might be able to swim away, and often the fish will do that to get out of the hypoxic zone. The problem with that is that studies have shown, particularly down in the southeast, that fish that are swimming away from the hypoxic or the low oxygen area are really only going as far as they need to get the oxygen that they need. But that pressures the fish that are where these fish have traveled to. So you start getting, you know, competition going and a crowding of fish in areas. If you are a bottom mover, like a lobster or a crab, you can probably move away depending on how big the extent of the hypoxia is, or if you're traveling in the right direction. But if you are this beautiful anemone, you are fixed to the bottom. And that makes a difference because you don't have a choice. So we can start getting desert-like appearances at the bottom of Long Island Sound because of hypoxia, depending on how severe it is, how long it lasts, how often it occurs. So that's a big issue for Long Island Sound. Now, plants to the rescue. That was a long way of getting towards talking about plants, because as gardeners, we love plants. So we're ready and willing to use plants as a tool. Plants come to the rescue of so many of the issues of the environment in general. Plants have a tremendous ability, particularly with soils. It can hold back and process contaminated water. So in other words, buffers. The picture on the top is a natural buffer that's along an inlet along the Connecticut River. And you can see that there's a lot of diversity of species there, there's a lot of competition, but plants have a way of figuring out how to work together. That's part of what nature does so incredibly well. And you could see that if there is polluted water somehow coming towards this water body on the top, it's going to be intercepted by plants. And plants have a tremendous, between the soil and the plant tissue itself, excess anything, pollutants, contaminants can either be slowed down, they can be broken apart, they can be volatilized through the air, they can be incorporated into the plant matter. There's many different ways that plants can actually really assist with keeping water clean. And this is why I always encourage folks, if you live on water, if you live directly on the Sound, if you live on a pond, if you live near a stream, that even a 10-foot buffer of a diverse cover of vegetation can go a long way towards keeping water clean. And also in the water, in our shallow, in the estuary, we have, you know, shallow shorelines, and that's where we get our coastal marshes. And those also are doing an extraordinary job of providing habitat, protecting the inland portion of our landscape, but also helping to hold carbon, which is important, and help purify. Now, if we're talking from a gardening perspective, the types of plants that we use are key, and this is where native plants come in. There are specific definitions for native plants, and I could do a whole nother talk just on how we come to an understanding of what native actually is. But the important thing when somebody says, if you go to a nursery and say, I'm looking for a native plant, always ask them native to where, because you can get a Colorado blue spruce and it's native to North America. So there are nuances. And what you'd ideally like is native plants that are native to Connecticut. They have grown here, they have a long history here, and I'll explain why that's, as we go on here, why that's important. So that's probably the most important thing you can do in going to a nursery and asking about native plants is there are connections to native plants, and this is what Doug Ptolemy gets involved in talking about, is that this swallowtail butterfly in the making, on the left of this picture here, is targeting certain plants that are necessary as a larva in this case, and then as a adult butterfly is going to look for another very specific plant. And native plants, when you plant them in our landscape, because they have co-evolved, because they are a part of the landscape, they can live here without significant inputs of fertilizer, pesticides, water. There are a lot of good things to that statement, because if you don't have to feed the plants, if you don't need to use pesticides to get rid of bugs, now some of that is understanding bugs, but also even just, right plant, right place. So that's part of why understanding what native is and asking for native and trying to educate yourself about what's native is really important. The relationships that define what native is in any place, in our backyard, in Connecticut, and particularly Connecticut coastal, the relationship has been built over a long period of time. And that's part of what makes it so strong. There are so many nuances. There are so many ways that nature interrelates, whether that's through individual plants, or whether it's plants and insects, whether it's ultimately what's provided as resources for the wildlife that we love. There's so many different ways that over hundreds and sometimes thousands of years that evolution has locked in what makes our local ecosystems productive, what makes them work. So when you start introducing non-native and then unfortunately invasive species, whether they're brought in, many of them through the horticultural trade, but also some of them just because we travel, where we bring things with us for various reasons, and those start to run amok in our local ecosystems. The other thing with native plants is that they provide the resources in sync with when the organisms that rely on them need it. This is part of why biologists and botanists in particular are really concerned about climate change, because of the potential for what's called decoupling of resources. So if we start getting a rapid change in temperatures and the plant species can't keep up with it, and the insects that need the plant species therefore are not getting the resources that they need. Think of migratory birds that are looking for the power that comes from caterpillars, which is what Doug Ptolemy talks about so often. If that relationship time-wise breaks apart, then we start really messing with local ecosystems. And that also gives an advantage to some of the non-native aggressive plants that we get brought here from other means. The inset photograph there is also just hats off to the fact that we don't know everything about nature. We don't know all of the different relationships about what needs what. And even though we know a lot and we continue to investigate, something as simple as insects see ultraviolet, many of them do. So the flower that we see on the left as a brown-eyed Susan to a bee or to another insect that is looking for the nectar, is looking for specific resources, that plant is using ultraviolet to indicate, like landing strips, those red paths saying, here, go on these landing strips, because right in the center, that's where the nectar is that you need. And the insect, the bee, or whichever is visiting, is going to go to get the nectar, but in the process also pick up the pollen. And that's good for the plant, and it's good for the insect that's visited. Again, a time-honored system. And we think a lot more now about carbon. Where is carbon? How is carbon getting into the atmosphere, and how can we do something about carbon that's getting into the atmosphere, in addition to some of the more obvious ways that we have introduced carbon over the life of human intervention. So part of what we look at is anytime the soil is exposed, we're losing carbon to the atmosphere. And that's going to play into how we look at our gardens very shortly. So if you can keep rooted plants in the ground, and particularly a diversity of rooted plants and different types, because different plants will store at a different rate and different speeds, that you're also doing something to sequester carbon. And that's becoming more and more important as time goes on. And it's starting to make us look at how we garden, and not just our backyard gardens, but starting to look at how we produce food in our country and in other parts of the world. Okay, you knew I was going to get to grasses at some point, and I have to say that turf grasses are a big part of the story that can change. I do a whole program that's just on the history of our relationship to lawns in this country. It's very interesting, really. I mean, there are a lot of influences that came, you know, in the late 1700s into all through the 1800s. It's a fascinating story, and it's one that we can change. And I'm hopeful that people will look at lawns the way I do, which is, boy, they're a lot of work, especially when you could be doing gardening. But I get it. I get that lawns, you know, there is an appeal to lawn, but we don't need big lawns. And we certainly don't need large expanses of lawns that are being maintained with copious amounts of additives to them, whether that's, you know, 4-in-1-step products that provide sort of a one-size-fits-all food and pest control, as if every lawn was the same. We have a lot of lawn in this country, and you can see that the Northeast is among the most concentrated in terms of total amount of turf. An area the size of New England states, 75% of that is residential lawn. So we're really pinpointing exactly where we have sort of the low-hanging fruit of we could do something about this. Doesn't seem as though this number is slowing down. You know, if almost 400,000 acres of land is converted into lawns every year in North America. But I am hopeful, actually. I see more and more people who are at least asking themselves, if you want to keep your lawn, can you go organic? If you don't want to go organic, can you at least reduce the total amount of fertilizer that you're using? Can you reduce the type of fertilizer that you're using? Can you introduce different species other than Kentucky bluegrass, some more grasses like fescues that can live in our climate a little bit easier than a water-intensive and food-intensive species. So there are many different shades of looking at our lawns. So let's look at fertilizer, because that's a really important part of the equation. I have to tell you that this picture I took of my neighbor's front yard, I lovingly refer to him as Mr. Hypoxia, mostly because there are times when I'm convinced that he alone could be responsible for the hypoxic zone in Long Island Sound. He is very enthusiastic about his lawn and about his very large yard and his gardens. And I have yet to figure out how to engage in a conversation with him about that, because he loves his yard and he's a nice man. I mean, he's not a bad neighbor. I'm fit to be tied to try to figure out where to begin. But this photograph that I took, you can see there's some on the sidewalk here. You can see the little white grains. One of the low-hanging fruits that you can do is, if you are fertilizing your lawn before the rain, as many people do, and you're applying it with a with a cart, is to turn it off when you go across hard surfaces like a driveway or a sidewalk, because these little specks of high concentration fertilizer are not going to be taken down into the soil. And in fact, with the next rain, there's a good likelihood that they're going to be caught up in stormwater and go direct discharge into, in fact, right where this person is walking here, walked past me, there is a storm drain. So that's just low-hanging fruit. That's a fairly straightforward thing that can be done. Plus it saves in fertilizer application. So the only way that you can tell if you need fertilizer is to get a soil test. You can do that at Yukon. It's fairly inexpensive to do it. The tough thing is that in the spring, when everybody is excited about getting back to their yards, that's the heaviest time for the soil reporting time. The best time for getting that information would be in the fall to do a test and to keep the test. I've been told the best way to do this is to keep that information. So from year to year, as you retest, you can get a better sense. You can fine tune if you in fact need fertilizer, what type of fertilizer you need. The other thing is to account for other sources of nitrogen. You know, we have atmospheric nitrogen, a fair amount of atmospheric nitrogen where we live. Some of that's coming from automobile exhaust. And of course, we're in shouting distance of New York City, and we've got a fairly populated, you know, coast-intensive car corridor. So that's a contribution. Also, lawn clippings. If you're leaving your lawn clippings, which is generally recommended, that's just cutting off the top of the plant and reintroducing that as food for your lawn. And since grass has nitrogen in it, then you're reintroducing nitrogen. So take that into account. And if you use corn gluten, some people will use this to try to control grubs. That also is contributing nitrogen. So a lot of these things you're already getting nitrogen into your lawn system. So understand if you need more. There are general recommendations that have come out of all of the land grant colleges that did a great study on the relationship between lawns and water quality. I can send that document or send a link to that document if anybody wants it, because it's really amazing. But part of what they do is they say a maximum of 2 pounds per 1,000 square feet of fertilizer to your lawn if your lawn is 10 years or older. If you've just bought a new house, and we all know that, you know, the lawns are a default landscape when you buy, particularly in a new subdivision. And what they've done is scrape and compact soil around the house, scrape all of the good stuff off, and it gets very compacted. And then they come back and put in a very, very thin amount of any kind of soil and add seed to it. So you can go up to 3 pounds per 1,000 square feet if you have a young lawn that's new. No more than twice a year, and very importantly, no later than October 15th. So if you could do it one time, it would be between mid-September to mid-October. And the reason for not doing it beyond October is that once it gets cold, any fertilizer that you put down is not being absorbed by your grass anyway. So that becomes, again, something that goes just quickly into the ground and has the potential for contamination. And if we start thinking about biological diversity, which Doug Ptolemy would love us to be thinking, particularly having to do with the small things that run the world, as E.O. Wilson would say, to a bee, a lawn is a desert. It really, it doesn't produce seeds. It doesn't have any nectar from flowers. There are few ways that organisms can utilize a lawn as habitat. So when we look at the total amount of acreage of lawns that we have in this country, and think of what we could be doing in terms of habitat. The house on the left, the front yard is, I passed this house I used to pass this house every morning on my way into work. And it's an example of someone who has taken, albeit a very small area, but they've really highly concentrated of diversity of plants. And I think that's a great system. It's not necessarily an easier way. I mean, that needs maintenance, you know, things need to be cut back or at least managed, but it is from an ecological perspective, from a habitat perspective, that lawn is doing a lot more, or that front yard is doing a lot more than if it were completely converted to lawn. And the picture on the right is my lawn. I try to keep corridors so that I have, you know, 4 to sometimes in areas 6 feet, so I can get my garden cart around my yard, but everything else is in gardens. And last year I had an explosion of Asclepias, the milkweed plants, and they were so lovely and they were so productive that I decided I would just let them take their part of the lawn and let that part of the lawn go. I haven't decided yet this year. I haven't seen them emerging to see what I've got this year, whether I'll go back to mowing it or not. The other thing is to reconsider your use of pesticides. I take this picture. This is another neighbor of mine who has a lawn service that's called Natural Lawn of America. You don't need to choose between a healthy lawn and a healthy family. And yet right next to it is a pesticide application sign. So there's a lot of confusion. There's a lot of lack of information in the general availability of people to care for lawns. And that's a problem. There are people who are not qualified to be doing pesticide applications, and there are people who just, there's a difference, and I get this information from people who I give talks to, and they say, you know, we have a lawn care service, and you know, we speak to one person, and then the people who show up to actually do the lawn are not the same people that we spoke with, and I don't know what they're doing. I don't know what they're applying. I don't know, you know, so they'll do it while I'm away at work. There's a lot of problems inherent in this, and I know that there are efforts to try to fix this, but pesticides are problematic. I think we only need to look at DDT as a cautionary example, but also the neonicotinoids that are sort of the more current family of pesticides that are used have been implicated in the decline of honeybees and other insect species. So here are some recommendations. Nurture the soil. The soil is so incredibly important to the beginning of a healthy ecosystem. I mean, you could argue that without a good, healthy soil, that everything else that you're going to try to do to provide habitat or to enhance your garden, whether it's vegetable or you know, flowers, is going to rely on, in particular, the soil food web. If you think about what's below your feet, we tend to think of biodiversity as being in a forest or in some other place that has a lot of things that we can see. But what's remarkable is, you know, this quote, more soil microorganisms in a teaspoon of healthy soil than there are people on the earth. That's the Natural Resources Conservation Service, which used to be the Soil Conservation Service, quote. There's just an extraordinary amount of life, diversity of life, and it's a fascinating story, and we're getting so much more information now and research. Susan Samard has done an amazing amount of work on the relationship between fungi in the soil and trees, and the relationship between plants that harness the sun's energy and bring that down into their roots, and then exchange with fungi some of the resources that the tree can't get access to through its root system. And then there's a whole other, you know, communication that's going on. It's a fascinating world below the earth, below our feet. And so to the extent that you can keep your soil healthy, and some of that is just a diversity of plants on top of the soil that are using, you know, what you do with your garden. So here are some of the things that you can do. Minimize disturbance, because we know now a whole lot more about the role of mycorrhizae, fungi, about the relationship between all of the organisms that are in the soil, so that when you rototill your soil, you're actually destroying a lot of the organisms that then have to rebuild after you've rototilled. I mean, it was common practice. When I first moved to my house, I borrowed my dad's rototiller, and I was so excited about starting my garden and rototilling. And I realize now, just in retrospect, that that was probably the worst thing that I could do to start a garden. So minimize disturbance, and this is why we're starting to see no-till agriculture, which is really the idea behind that is you make a slit in a soil that has got a lot of organic material that has just been left there, and in that slit you put the seed or you put the plant, and that is worlds better for the soil. The other is to maximize the diversity of plants and root types. So have some plants that are like carrot roots, have some plants that have fibrous roots, have plants that have different means of communicating and using different tiers of the soil. And not only will you get that relationship between the above ground plants and photosynthesis, but you'll also get the relationships between the organisms below the soil that has to do with soil life, whether that's as small as the fungi and algae and microorganisms to the things that we can see, some of the pill bugs and the millipedes and all of the organisms that, worms, those kinds of things. Keep live and living roots in the soil as much as you can, which means if you can do a cover crop on your garden bed over the winter, that's going to help not only keeping protection over the soil, but it's also going to, when you turn that under in the spring, or if you just cut it down in the spring, it's going to add the mulch materials, and it's going to protect the soil from being just bare, which farmers, we used to historically do that, just leave the soil open. And again, cover the soil with plants and plant residue. And that reminds me of the Xerces Society, which if you are interested in knowing more about our invertebrate partners, the Xerces Society, which is spelled XERCES.org, it is the first, and as far as I know, the only major, or at least nationwide, invertebrate conservation group. It actually had its roots here in Connecticut at Yale, and it has gone on to expand tremendously. And they have also a tremendous YouTube site where you can see all of the presentations that they give and webinars. One of their campaigns is "Leaves are not litter, leave the leaves." So if you have leaves that come down, obviously leaves and lawn are not terribly competitive, but you can take the leaves and put them into your garden or put them below your shrubs. And the important thing about if you can leave the leaves is that, as Doug Ptolemy tells us, so many of the organisms, good and bad, in terms of insects, will drop and reproduce or somehow travel to the soil and use the duff layer below the leaves and the nutrients that are coming from the leaves to pupate, to otherwise, do their life cycle. So if we're blowing our leaves off or we're shredding our leaves, we're also taking all of the insects and the organisms that are associated with the plants that those leaves have been produced from. So maybe also consider reducing your lawn area in favor of wildlife. This is my backyard I have to say that, if you see a nice picture of my garden, it's because I've actually taken it at a nice time of the day and from a nice angle, because my yard also can be very messy. It's very messy right now because I'm digging things up in particular. But that's also, gardens can be messy, and that's part of the culture of how we're changing. A lot of the literature that's come out in the last 5 years, a lot of the really interesting books, Planting for a Post-Wild World, are talking about relaxing our expectations about how neat gardens need to be, because nature is not neat. And as you define, what's important, organic material is important to leave, and that's not always pretty. But there are organizations, the National Wildlife Federation, again, the Xerces Society, there are all kinds of programs that certify now, that provide tremendous resources if you want to convert your lawn or your yard into more wildlife habitat. And Doug Ptolemy will tell us that, you know, it doesn't matter how big the scale is. And his hope in his latest book called Nature's Best Hope is that if we were to look at all of the neighborhoods, particularly true along our Long Island Sound coast, how concentrated our houses are. This is Old Saybrook in the background here. And, you know, if you look at the scale of where nature can resuscitate, it can be very small. I mean, you might have a very small backyard. You might have just a patio. You can start with a pot and introduce the means for providing for pollinators or for just providing what plants provide, which can, at the very least, can help clean air. So if you look at connecting neighborhoods, either through visible corridors or just by providing resources, if you think that, you know, our smallest bees can fly only 3 blocks before they need to refuel on nectar, well, that's going to be their only hope if we can provide those kinds of resources from neighborhood to neighborhood, because those insects are going to need to find those resources or they won't be able to reproduce. And that can be even, you know, fields or lots. The lot on the top picture here is a lot in Saybrook that had a house on it. They tore the house down, and I went in there just to investigate what the diversity of plant life was, and it was so diverse in there, even though it was surrounded by Stop and Shop on one side and H&R Block on the other side. Although I'm sad to say it has just sold and it is going into a development. Some interesting things, you know, this is not just about you know, helping nature, although that is a great reason to do it. It also helps us. I mean, if you can start to look at what's around us and how interesting it is and how diverse, insects in particular, but, you know, plants, there's so many things. You can become a bird watcher if you're not already. I think that insects are fascinating, and you know, the statistics, 25% of our native bees nest in cavities, which can include rock piles. You can create a rock pile just in your own backyard. I've done this with round boulders. It creates nooks and crannies that they can use. Wood, beech wood, or wood that you can get from, even just a rotting piece of wood you can put down. 75% of the rest of our bees are ground nesters. And this is a picture that I happened to walk past a school in town, and I saw that on the left-hand side, you can see those little tiny mounds. And I went to investigate them because we have these ground nesting bees and you just have to look for them. And this is about the time of year, as it warms up, you'll start to see them emerge in the spring. And on the right is what I found as I got closer to that school. I can't think of a better way to have kids get excited about nature than to just look outside the window of that classroom and look at this concentration of little mounds here. It looks like an ant mound, but it's the hole's about the size of your pinky or the size of a pencil. And that is where any number of our ground nesting bees that have been there maturing over the winter are going to emerge. The female will do this all in the fall. She'll create the tunnel, and she'll create the little corridors off of that main area, the tube. She will gather pollen and nectar together and put it in a little ball. It's called bee bread, and she'll put that in as a provision, and then she'll lay her egg on that provision. And then that's the end of it. She never sees her young. And she'll close it up, and then that's the end of her life cycle. Over the winter, these insects will mature. They'll eat the pollen, the bee bread, and then they will mature and climb out of that hole and start their life cycle. And these are happening everywhere. It's just amazing to me. The more I know what to look for, the more I see these things, and then I see, you know, lawns where these are occurring, getting mowed and getting treated with herbicides and pesticides. So part of the way that you can allow these life cycles to happen and have it still be compatible is to leave some areas not so densely populated with plants and or even some bare areas. You can refrain from using mulch all around your garden, because any place where it's bare and it's warm, like particularly a south facing slope, is you have the potential for these. I've only had a few of them, like maybe 5 or 6 of them. I had some in my front yard and I had some in my backyard that emerged, and they're sporadic. They'll do it some years and not other years, but it's so great to find them. The other thing is to leave some dead trees or wood. If you have woods and you can leave trees standing, they are producing habitat right there. The piece of wood on the right is because of our state DOT clearing so many of our roadways of late. I actually found this piece of wood that was already cut such that I could pick it up and put it in my car. And it already had holes in it, natural holes that had been, the tree had been rotting. So I brought that and put it back into a section of my garden. And I can already see that there are things exploring and eating the dead wood. The picture on the left is, I don't know what those holes are. I would not be surprised if they were from bees. But again, wood is decomposed. In fact, I've heard it said that dead wood has more life in it than living wood. And I would not be surprised, either standing dead wood or wood that's on the ground. This is another thing that can be so helpful. And Heather Holmes, who is a bee specialist, she's from the Midwest. She's written some terrific books. She's had great webinars. And she also spoke for the Connecticut Botanical Garden here a couple springs ago. And we asked in the audience, after she got through with her talk about bees, because what she had recommended is that there are a fair amount of bees that will use hollow stems from flowers, Joe Pye weed or phlox, as you can see on the right, Monarda, the mints. A lot of those, if you leave those stalks over the winter, they are the perfect place for stem bees that use stems, hollow stems, to grow. So you can leave those up over the winter, but this is where we get into the messy talk again, where people don't like the look of that. So Heather, when we asked Heather about that, she said, leave 12 to 18 inches. If you can do that, then you're at least providing a possibility that the insects are still going to use it, and you snap the top off so that they can see the hole there. Or you can take the tops, which I've done, and just create a pile and put them in another part of your garden where you are willing to accommodate a little pile that looks messy. Now, I left the ones on the right with the phlox, and as the phlox grew up, it grew right up through them. So, and that's what nature would do on its own. So again, when you think about your gardens, if you can leave material vegetation over the winter, you're leaving a lot of insects. And as Doug Ptolemy says, people are so worried about insects that they're going to be bad insects. But if you leave the full spectrum of insects, there's a pretty good balance that that keeps the bad insects, or the insects that you don't want, down and allows for the food source that's going to feed all the other organisms. So I sort of like the look of this during the winter. And I have to say that right outside my kitchen window, I noticed one year that I had praying mantis, an egg case on one of the branches. Now, praying mantis are not native, but they provide a lot of resources in that kind of styrofoam egg case that they put over the winter. And of course, they'll do several of those with the hope that they'll make it through the winter, and that will provide for their continuum. But I noticed that when we had a particularly bad winter a number of years ago, that praying mantis egg case outside my kitchen window was visited by both chickadees and titmice, who were wailing away at it, going at the larvae. And that was during a very cold winter when food was short, and what the birds knew was, I'm going to find resources that I need when I need it. And it just so happens that that larva was very high protein and not real good for the success of those particular praying mantis that following spring, but it might have made all the difference to the bird species that needed it during the winter. So I'm hoping that there's a changing aesthetic. I'm hoping that over time we're starting to see the value of using the right plant in the right place. This is a development, it's the Middlesex Hospital Shoreline Clinic, not very far from where I am. And they hired somebody to do a native, all of the plants, all the plantings are native. And they put this great kind of hard scrabble meadow. And I call it hard scrabble because you can see if you look down on the ground that there's areas of soil that are open in between the clump bunch grasses and bunch flowers. I think that's beautiful, but I also think that it's fantastic because if you're a ground nesting bee, you can use access to that soil, and it's still, there's still an aesthetic here when you're driving by that looks lovely. And if you haven't been to the Highline Trail, the park in New York City, I so recommend it because that is mostly native plants, and the design of that was purposeful in showing and demonstrating how native plants can be very beautiful. And the success of that has been, I think, very encouraging because it says, yeah, people can embrace this look. And, you know, property values have gone up because of, you know, for all of the real estate that has a view to this, people gravitate to this because it's nature in the middle of the city. But it also is a great demonstration site. And you can go on their website and it has a list of all the plants that they've planted there, all the native plants. And if that all is not enough, then I will give you this quote, which I absolutely love. This is from Margaret Rankel, who writes for the New York Times. And she says, "I can remind myself all day long, every day, that there's a difference between doing something and doing nothing. That something, small as it might seem, is not nothing. The space between them is far apart, limitless, stretching distances apart. It's the difference between a heartbeat and silence."
Well, thank you. Lots of valuable information.
Thank you.
Shall I ask you the questions or?
Oh, sure.
Okay, how do we protect our wildlife when their habitat is being destroyed by the removal of invasives?
Yeah, invasives are such a difficult issue because it's, you can argue that you need to remove the invasives because the invasives are not providing the resources that the wildlife need to begin with. So I have a lot of concern about invasives in general, in part because they're so good at what they do, and we've brought them here without fear of natural predators for them. So they have, not only do they have an advantage, but as we see a warming climate, there's every indication that the very things that make those plants successful is also going to be enhanced by, in our case, a warming climate. I guess what I tell myself is to educate yourself about what is invasive. So A, you're not purchasing it. B, you can talk to a nursery that's carrying it. And unfortunately, we have things like barberry and there's so many invasives that are still being sold. But also that you can be sure to get to it in your own yard before it becomes prolific. I made the mistake, 26 years ago of when I bought my house, I had porcelainberry and it was so pretty. Mm-hmm. And I left it, and I still battled with that plant. I mean, I've gone a long way to getting it out, but I'm not sure that I'm ever going to completely rid my yard of porcelainberry. And that's sort of the only cautionary thing that I can say in terms of, there are people who still argue in the conservation community that the use of pesticides is absolutely critical to controlling invasive species. And they may be right. And that just makes me very uncomfortable. Mm-hmm. I still think that we not only do we not have enough information about the impacts, but we don't have enough information about the synergistic effects of when you use one with another, or it's a dangerous road to go down.
Mm-hmm. Mm-hmm. Is it true that cattails in the marshlands indicate that the water they grow in is polluted?
No, not at all. But cattails are terrific at cleaning water. So is Phragmites, I have to say.
Oh, really?
Yes. Yeah, a lot of these wetland plants are very well adapted to taking excess nutrients, in particular, out of the water. The problem with both of those plants is that they can be bullies.
They can be what?
Bullies.
Okay,
You know,
that was
Phragmites.
the next question was, do Phragmites serve any positive purpose?
Poor Phragmites.
Yeah.
It's interesting because I'm dealing with a group of people on the Connecticut River with a new invasive, very new, called hydrilla, which is a submerged aquatic plant. And it has just, the rate at which it has overtaken the coves and the smaller, quieter areas in the river is so profoundly fast. And it turns out that Greg Bugby at the Connecticut Ag Experiment Station thinks that we have a new species, that it's
Wow.
it's a new, it's kind of like what we did with Phragmites. You know, this idea that we do have a native Phragmites, but it was way out competed by a non-native Phragmites that has become very successful.
Mhm.
So,
But Phragmites can keep water clean. It's just that they kind of do too good a job of taking over the area around them.
you can control Phragmites. Again, at the smaller the scale, the better the chances that you can do it without chemicals.
Uh-huh.
You know, you can rob it. The state has worked for years at, you know, they will use pesticides or herbicides, I should say, for that. But they've also found that repeated cutting at the latest point in the season, when the maximum amount of energy is been put above ground, that you're really disadvantaging the vigor of the plant.
Oh, that's interesting. And then somebody wrote, thank you.
Well, thank you for the opportunity.
I thank you too. It was a lot of valuable information.
Good. I think you are a receptive audience. Always nice.
Okay, I guess thank you for coming, and well, I'm glad you didn't have to come from Saybrook.
At this point, I'm looking forward to traveling to see folks.
Are you?
I mean, this is a good, you know, it is a great opportunity to be able to, and actually you can reach lots and lots of people, but I miss not having face contact with people. I think that it's more, it's better to be with people. But
Yeah, I guess it says something negative about you if you don't miss it.
Well, and it seems very possible that by the time we do our fall series, that we may actually be able to come together
yeah,
and be in the same room. Get back to having these at Trinity with be able to live stream them, and so we look forward to that. This has been helpful, but it's so much better to be in the room together.
yeah, I agree. But then there are probably people who wouldn't go out and now have the opportunity. So I don't think
Exactly.
we're ever going to be 100% one way or the other. Which is okay.
Exactly. But I loved your information and presentation, and thank you.
Good. Well, thank you. Thanks for your interest, everyone.
Thank you, Judy.
Right, good night.
Thanks and good night.
And nice to see everyone.
Thank you. Good night.
Good night.
Night.